demonstrating the addition and the multiplication properties. For example, 2a, we want to figure out what numbers will make this inequality true. We have x minus 2 being less than 1. We're going to use opposite operations to isolate the x, get it on one side of the inequality by itself, and all the numbers on the other side. So I will add 2 to both sides here, and I'll end up with x less than 3. If I want to write my answer in interval notation, I'll be taking all of the numbers that are going from negative infinity up to 3, not including the endpoints. For example B, I'll use the opposite of adding 10. I will subtract 10 from both sides. And so we get that x is less than negative 25. For interval notation, I would have numbers from between negative infinity going up to negative 25, again, not including either of the endpoints. For example C, the variable is being multiplied by a number. So I'm going to use division to get the x by itself. I'll divide both sides by 4, and I end up with x greater than or equal to 1/2. In interval notation, I would have 1/2 as the lower bound. I have a square bracket to include the 1/2, and then going up to positive infinity. For letter D, we have to do something slightly different because we're multiplying by a negative sign. When I think about the order of numbers on the number line, on the right-hand side, when I'm looking at positive numbers, a number like 5 is greater than or to the right of 2. But when I'm on the other side, looking at the negative numbers, the order is in reverse. Everything is going in the opposite order. And so negative 5 is to the left of negative 2, right? They're in the reverse order from one another between this and this. So when we multiply or divide by a negative number, what we do is we have to switch the sign. The inequality sign switches to the other direction. So for this example, I'm going to divide by negative 5. But when I simplify this, I'm going to take the inequality and switch it to be greater than or equal to. 35 divided by negative 5 is negative 7. So my answer here is going to look like negative 7, including the endpoint, and then going up to positive infinity. All my x's are greater than or equal to negative 7. What we'll do now is combine all of those ideas together and solve inequalities that have one variable. I have a couple of different things that are happening in example A. 3 is being multiplied by x, and then negative 2 is being and then the 2 is being subtracted. So we have to remember to go in the opposite order of the order of operations. So I'm going to start by adding 2 to both sides, and then I will divide both sides by 3. So I'm getting that x is less than 1. For the next example, I've got x's on both sides of the inequality sign. And I have choices. I want to get all of the x's onto one side and all the numbers onto the other. I could move the 4x over to the right-hand side, but then I'll end up with a negative number. And if I have the option, I want to try to keep the variable positive so I don't have to worry about switching the inequality sign when I multiply or divide by a negative number. So instead, I'm going to move the 2x over to the left by subtracting 2x on both sides. And then I will subtract 7 from both sides. And then I will divide by 2. So we're getting that x is greater than or equal to negative 5. For this example, I have a negative x on the left and I have a 1/2 x on the right. Before I get started, I think I might want to try to get rid of the fractions just to keep it a little bit easier. So what I'm going to do is I'm going to multiply both sides of this equation by 2 so that I can clear the fraction. That'll be a negative 2x plus 8. And then 2 times 1/2, that's just, those are going to multiply to give me a 1, which is why I chose the 2 to clear that denominator. And so I'll have x plus 2. I'm going to now add 2x to both sides, so that way I'll get the variable to be positive. So we get 8 less than 3x plus 2. Let's subtract 2 from both sides. So 6 is less than 3x, and then we'll divide by 3. So I'm getting that x is greater than 2. I want to use that same idea of clearing denominators in this inequality. So I need to first figure out what the least common denominator is. So let's see. I have 6, which is 2 times 3. I have 4, which is 2 times 2. And then I have 3, which is just 3. So it looks like I need a 2 and a 3 for the 6. 3 will be already included in that. But here I need to have 2 2's, so I need another 2 here. Looks like my least common denominator is 12. So as a very first step, I'm going to multiply both sides by 12. All right. When you're multiplying by a whole number, what you want to do is think about dividing first. 6 goes into 12 twice, and then the 2 is going to multiply by the 5, so that's going to be a negative 10x. So I divide first. 6 divides into 12. I have a 2 left over. 2 times negative 5 is negative 10. Let's go over to the other side. Looking at this fraction first, the 4 is going to divide into the 12 3 times, and then 3 times 3 is 9. And then moving to this fraction, 3 divides into 12 4 times. 4 times 8 is 32, so plus 32x. So now I'll add 10x to both sides. I want to keep the variable positive, so I'll have 0 less than or equal to 9 plus 42x. Then we'll subtract 9 from both sides. And then I'll divide both sides by 42. I think I can simplify this fraction a little bit. Both 9 and 42 are divisible by 3. So it looks like we get negative 3 over 14 as our final answer. So x's that are greater than negative 3 over 14.